Hey, it's Nadav. I'm on eBoz's channel. We're going to do a short little introduction, a short little explanation of substance exchange. Yeah, let's take it away.
Yeah, so you can see in this picture you have a blood vessel,
Just a little hot dog.
and towards the left is the arterial end, middle capillary to the right is the venous end. And as you can see, the blood pressure is constantly decreasing as you go from left to right, and that's simply because this picture doesn't show it too well, but the capillary system is very long and convoluted, so the blood has a long time to lose its pressure. So you can see it in the beginning it's 32 and it ends at 15. It's a pretty big difference. What doesn't change, however, is the osmotic pressure. It stays at a consistent 22 millimmercury the whole time. And the reason for this is because what determines the osmotic pressure is the concentration of kind of big solutes in the blood, like albumin and those kind of blood proteins that determine the osmolarity. And those can't diffuse out of the blood vessel because the pores are way too small. All that can diffuse out are like small things, salt, H2O, etc. So because the proteins don't diffuse out, the osmotic pressure stays the same, and all that decreases is the blood pressure. Now, a basic concept is that fluids and substances move from high to low pressures. So at the beginning, the blood pressure is higher than the osmotic pressure. That means that stuff is going to move outside of the blood vessel and into the interstitial fluid, and from there, hopefully into the tissue cells. And a quick fact here is that 10% of that fluid and solutes and whatnot, 10% of it stays. Yeah, 10% of it stays in the interstitial fluid. So that has to be picked up by the lymphatic system. The 90% of the fluid, the rest of the fluid, comes back into the blood vessel towards the venous end. And the reason this happens is because, as I said earlier, stuff moves from high to low pressure. So as the blood pressure is decreasing and the osmotic pressure stays the same, the net pressure, as you can see on the right arrow, is -7. So stuff is going to move into the blood vessel. And what moves in is water, the solutes, and CO2. And I didn't mention this earlier, but O2 leaves on the left side. That's probably one of the most important things that the blood vessel is carrying. So yeah, that pretty much does it for this picture, and we have an explanation for the second
Yeah, I'll
picture
explain
as
the
well.
second one, but first I have a joke. Okay, so not really a joke, more of a story. Eos and I, little kids, best of friends, like little 7-year-olds, and we went to the doctor.
PB and J.
PB
That's how
and
close
J,
we were.
like a sandwich. Okay, we went to the doctor, and well, we actually didn't go to the doctor together. We actually ended up meeting up there, and Eos was just sitting there outside, crying his little butt off. And I wondered, why are you crying, little Eos? He goes, have you seen the doctor yet? And he said, no, I haven't seen the doctor, but I had my blood exam, and when they checked my blood, they cut off my finger. And then I immediately blew up, like crying, not laughing. I was crying my bums off, and then he asked me why I was crying because, well, and I was bawling my balls off because, well, I was in for the urine test. Come on, give it up. All right, I know. All right. All right, I'm going to quickly explain this graph you see down here at the bottom. Basically, think of this as like the capillary. So the capillary here is the arterial end, and here's the venule end. And the blood pressure starts off much higher than the osmotic pressure at the beginning, and then it constantly decreases as you go along the capillary. And at this point right here, once they're even, no exchange is happening. At the point where blood pressure is always higher than osmotic pressure is outward flow. Since the pressure is higher inside, water and stuff moves outside in order to achieve equilibrium. At this point where they're even, no exchange is happening, and right here, once it's lower, it ends up actually being the higher concentration on the outside, and so stuff is coming back into the capillary.
Yeah, and just to clarify, when he says stuff coming outside of the capillary, he means that it's going into the interstitial fluid, because it doesn't go directly in the tissue cells. and there's a little space in between them. But mostly after it goes into interstitial fluid, it will enter the tissue cells. And also, as you can see, the red blood cells are pretty much, they make up the width of the capillary. So you can only have like one red blood cell going through a space at a time. And you can see a pretty nice picture in the top left corner of that.
Right.
Got much time. Yeah, so that does it for this video. We hope you learned something.
Leave a like, leave a comment, share this shit, give it to everybody you know, get this out there.
Amen.
We'll see you first hour anatomy.
He meant share this stuff, not...
No, that's definitely what I said. Share this stuff. Adios.
That's the wrong unit.